Hey guys, in this video we're going to be covering target 4B.2. Our mastery learning objective is I can identify the restricted domain in context of a real-world quadratic. So, using the same colors and vocab from the last video, so if you want to get those same colors out so you can color code everything again, that's fine. I'm going to keep it the same as the previous video. So, looking at that first question, it says determine the interval where the seller earns revenue. Revenue is just meaning profit. So if the seller is earning revenue, well, first off, this means profit, in case you didn't know. And where they earn a profit is wherever our graph is positive, right? Remember, this means above the x-axis. Above the x-axis. All right, just as a reminder. So where is our function above the x-axis? I find that intersection point, which tells me that this value right here, that's going to be at an x equaling, what is that, 2. And then my vertex, not a vertex, but my x-intercept, apologies, is going to be right here at x equaling a 15. So between those 2 points is where my graph is positive. So that is where my seller is making revenue. So from 2 to 15, and he is making a revenue. Determine the interval where the revenue is increasing. So increasing just means where is that graph going up? So my graph is going up from here up until this point. Looking at that, I can only be using my real world context right there. So that's the x value of 2 until we get to this point right here, which looks to be at 9. Or not so much because 9 would be in the middle there. So this would be like 8.5. So this is going to be from 2 all the way to 8.5 is where my graph is going up, right? Where it's going positive. Where is the interval where the revenue is decreasing? So decreasing is wherever it's going down. So that's going to be from that same x value all the way going down here. So our x value is still our 8.5. But now it's going all the way onto that 14, right? Or actually, I think it's 15. Yep, it's at 15. At what price does the seller make the most? So the most is going to be what is that highest, what is that vertex point, right? So our vertex point here, at what price does he make the most money? So price is going to be our x-axis. So it's going to be whatever we decided that x value was going to be for that vertex point right there. That is the highest point, right? That's why we use the most. And then the price was, well, price is in dollars. So that's going to be at $8.50. All right. Looking at the next example. Determine the interval where the diver is in the air. So looking at when he is in the air is talking again when the value is positive, right? Where is he above the x-axis? So x-axis, he's right here actually at 0. So it's going to be from 0 until this value right here, and that seems to be at x equaling a 3.5. So from 0 to 3.5, our diver is in the air. Determine the interval where the height is increasing. So where is he going up? Well, starting at this value right here, until we get to this value right here, I have to use those x values. So this is going to be from 0 until 1. Our diver is increasing his height. Where is he decreasing? From that same value all the way now going down. But again, we use those x values, so that's going to be from 1 until 3.5. And what time is the diver at her highest point? So our diver, the highest point is going to be where that switch happens, right, from positive to negative. But if it's asking you the time, this is our x-axis, right? It's not asking you what her highest point is. her highest point occurs at 1 second. Alright, looking at example number 3. This graph shows the cost of to produce a tennis ball. So determine the interval where the factory has negative cost. So this is where our graph is below, right? Negative means below the graph. So if I see first off, it's a lot easier sometimes to find those x-intercepts and see wherever it's positive, right? It's positive on the left of that point, and it's positive on the right of that point. So where is my function negative? Well, my function's negative all of this, right? So that's going to be between these x values. So that x value is going to be at x equals 28, right? So that's going to be from 28 until this x value right here, which is 72. Determine the interval where the cost is decreasing. So where is this going down? Decreasing from here up until this vertex point. So this is going to be from 0 until that vertex point, which happens to be at 50. Where is the interval increasing? This is where it's going up. Well, from that same vertex point all the way up here. Alright, so that's going to be from 50 until 100. Right? So remember, this is real world context. So this point is stopping at this value down here. How many tennis balls will the factory, we'll give the factory the lowest cost. So the lowest means that lowest point, right? This is going to be the vertex. Where is our vertex? And that was at this point right here. How many tennis balls? Well, tennis balls is our x-axis. So at what value does that happen at? And that would be right here at 50. So 50 tennis balls will give us our lowest cost. All right. So that brings us to the end of this video, 4B.2. You can go ahead and work on activity 4B.2 as well as that AB review. So remember that AB review, obviously covering everything from target A and target B. This last section is just putting all those vocab words from the previous video into context. Remember, we can't go off to infinity. We can't have time be negative. All those concepts are being put into these real-world problems. So still, words negative, increasing, decreasing, those words aren't going to change. But you just have to put it in context of whatever situation is happening. All right, good luck, guys.